Good morning to one and all present here. Welcome to the sixth webinar of the series, Gain Momentum, Unlock Your Potential, hosted by the Computer Department of Don Bosco Institute of Technology. I am Mansi Anandpurkar, your compare for the session. It is said that our intelligence is what makes us human, and artificial intelligence is an extension of that quality. In today's world, where almost everything is automated or improved using artificial intelligence, let us find out how we can make use of this technology to improve agriculture. But before that, I invite Dr. Amiya Kupar Tripathi, Professor in Computer Department, to introduce us with the speaker.
Good morning, everybody. Welcome to the webinar Digital Agriculture. In India, in agriculture, India is a land of contradictions. The country produces 11% of total global agriculture and at the same time is the host to the world's largest of malnourished people. Agriculture provides livelihood for our half of the Indian population, most of whom are small holders, farmers, yet a majority of government agriculture subsidies are used by the medium and large scale farmers. Parallel to India's tremendous success in the modernization of agriculture, smallholder farmers have been marginalized. The average debt of a farming household has risen fivefold in decade, while increase in the farm income have not kept up. Given the complexity of Indian agriculture, no single policy change or technology shift will move the country towards its dual goal for rising income for smallholder farmers and continuing to the strength of the competitiveness of the agriculture. But the digital transformation of agriculture occurring worldwide holds some promise for the progress. They offer insights illustrating fundamental changes in the structure of the sector and raise questions about whether smallholders farmers will benefit from the digital innovation in the same way that larger farmers will. A large number of digital technology have already been scaled up in a country with a 1.3 billion people with a 48% depend on the agriculture. When we talk of scaling up, what we mean is that we are able to reach 200 million farmers within 2 or 3 years. For example, India has now rolled out one of the most soil health management system of any country in the world. All the farmers in the country today get their soil tested once every few years on 12 parameters, on all the macronutrients and micronutrients, secondary nutrients, and physical and chemical properties. And the farmers get advice of the nutrient status. We are now looking forward of using a large number of digital technologies at the pre-production stage, in production, and post-productions. Moving from a production-centric to the market-centric infrastructure, for example, important impacts of digital innovation are being seen in the use of data to information making, policy making, and operational efficiency of governments at both federal and state level in India. Historically, most of the emphasis was on the data collection, not data utilization, with a focus on the production of data. So state by state, we have tremendous amount of data, but we have gaps, and we are not using that what we have well. We have a lot of crop cutting data, for instance, but we often don't know how much the farmers is earning. Ideally, we would have the data to understand a potential income gap, not just a potential yield gap, but in general, we are being more intentional but about the data we need and now how we use to make a good decision. We are making the shift from a what data to data what. Digital opportunities are there, but there are still major challenges. In Indian agriculture, we are under-technologized. Our lands are fragmented. There is a strong nexus between the economic and politics at the ground level. It takes bravery to jump in there and try and make some value of it. But this is actually changing with the digital innovation, digital agriculture. More generally, the impact of digital innovation on Indian agriculture will take time, obviously. Although we talk about mobile penetration rate on average across the country, the penetration of smartphone into rural area is actually still quite low. It is increasing rapidly, but we may have to be several years to go away from scaling type of services we talk in these areas. Indian farmers can be profitable, can be productive, can be progressive also. Digital will play a key role when you create a platform that farmers can use to get this digital knowledge on their cell phone. When they know how much they produce, how much they have sold, how much has come under cultivation, when they can see all the data in their own language on a cell phone on a real-time basis, and that is when the change starts taking place. And that's when you will start feeling, yes, it is doable. In India will always have a large number of small farmers, but small farmers can bring about a big change. They can be profitable, they can be productive and progressive, not all three put together. Now we have Dr. Leisa Armstrong, who has been pioneer in the agriculture since many years, right? And she is an eminent speaker across the world. I would like to introduce Dr. Leisa Armstrong. I'm very happy that she's with us in this webinar series. She has been colleague to me since several years. Dr. Armstrong has been working in academic and computer science discipline at Edith Cowan University since 2002. She has been working computer science related research in the area of agriculture, medical, education, tourism-based industries. Her focus is on the application of these technologies to solve the real-world problems. Before joining Edith Cowan University, she worked as an analyst programmer on a number of projects of Western Australia state government before joining this university. She also had previously owned a computer software consultancy company before joining university. She has worked for a number of years as agriculture research scientist with the Western Australia government on a number of grain industry related to projects. Dr. Armstrong is internationally recognized researcher in the area of digital agriculture and has a previous work as an agriculture scientist with more than 10 years research experience. She established and currently leads the e-agriculture research group at the Edith Cowan University. Her research expertise in the area of data mining, image processing in medical and agriculture system, agriculture informatics, agriculture production system, tools and decision systems, environmental sensor networks, mobile technologies, web and software systems. She has also developed expertise in the virtual reality education tools. She has supervised 8 PhD and 3 research master students and is currently supervising 4 PhD students working on various projects in the area of Western Australia, India, and Thailand. She has published widely the area of computer and agriculture science, including 12 journals, articles, 90 conference papers, 2 book chapters, and 5 reports and proceedings. Dr. Armstrong has successfully led both international and national research projects with international collaborators in India, Thailand, and Australia. Dr. Armstrong is also past president of Asian Federation of Information Technology in Agriculture. She has been invited keynote speaker at number of international conferences on sustainable technologies and computer science, has been conference convener for international conference and workshops. She has also been recognized internationally with the appointment as adjunct faculty and PhD guide at University of Mumbai, Don Bosco School of Technology, visiting professorship at IIT Bombay, Konkan University, Thailand, and IIIT Hyderabad in the last 5 years. And there are many more things which I'm not going to speak because there's time constraints over there. Dr. Leisa, you have been expertise in this area, and I welcome you to this webinar, and the stage is yours now, please.
Okay, thank you, Tripathi, for that glowing introduction. Can everybody hear me?
Yes.
Yes, ma'am.
Okay, good morning to all the students and colleagues in India, and good afternoon to all the people the students and my colleagues in Australia, and I don't know what time it is in other parts of the world, nighttime. So thank you for joining this webinar, and I'd like to just thank Dr. Tripathi for that really fantastic introduction to digital agriculture in India and the agricultural system in India. The topic of my presentation is on digital agriculture, and I'm going to be looking at how we can use different technologies such as artificial intelligence or image processing to improve the production and sustainability of the agricultural sector. And let's get going. I hope I can get, here we go. So the outline of my presentation today is just a bit of a background to agriculture and the challenges that are faced across the world and some of the issues that farmers also face in producing food. And then I'm going to look at some of the smart digital agricultural technologies and also look at the ways that we can use those technologies to help farmers make better decisions. And then delve into some of the research areas that both myself and other colleagues are looking at to improve the agricultural farming sectors across the world. It's predicted by the year 2050 that the world's population is going to be around 9 billion, and that means 9 billion mouths that need to be fed, clothed and watered, so to speak. So in terms of the agricultural sector, that provides a number of challenges for how we can produce enough food for those people. And in terms of the world, as we know now, we've got many different problems with pandemics and floods and locust plagues and droughts, hurricanes. All these factors are like really quite depressing, I suppose, for some of us. But we need to stay positive as to how we are going to solve this issue of securing food. And as an agricultural scientist previously and computer scientist now, that's like a really fun challenge. So the challenges that we have in terms of securing food is really how we can balance the demand for food and the future increasing demand for food with the actual supply of food. As the population increases, the actual areas of land which are available for food is actually decreasing. So we've got this kind of catch-22 situation where we need to improve the production of the food as well as find new types of food that can be produced in those areas. We also need to consider that there needs to be a fair access to food. So at the moment, the world produces enough food to feed the whole of the world's population, but there are still people that are hungry and starving, and that is a matter of politics and also just food distribution, in that why those certain communities are not getting enough food. There's also a need for the stability of food prices. And we will know that in many parts of the world, when we have different things like floods or droughts, the prices of stable food goes up. And that means that many of the poorer communities cannot afford those food staples. Another issue that we need to think of in terms of securing food is just how we're going to deal with the effects and the results of climate change, what strategies we're going to use, how can the agricultural sector and the IT sector work to help to solve those problems. And on the other front, we need to think about how we can maintain the biodiversity and the ecosystems while still being able to feed the world's increasing population. Oops. In terms of what farmers face, and this is the issues that farmers face is really true to not only what's happening in India, or it is also happening in Australia as well. And these are some of the issues that I've listed here. I think some of the really important issues is that that there are probably inadequate technology and access to technologies, poor infrastructure, and really high production costs, transport costs. And now we have just recently the issues of war or pandemics, which are detrimental to farmers and their livelihoods. And we also have other factors which are like natural disasters and other things like floods and drought, which is really driving the issues of how farmers can produce enough food for their livelihoods and also to sell. So digital technologies are really pervasive in all our lives in terms of all the different industries, defence, medical, entertainment, health, and it's also important in terms of agriculture. Some of these technologies have already been taken up quite easily in some of those other industries, but in terms of agriculture, the take-up and the adoption of these technologies has been a bit slower. So some of the technologies that we're talking about in terms of emerging technologies are those things like mobile computing, off-grid energy access, the use of computation, machine learning and AI, satellite imagery. We also have IoT associated with different data sensors and wireless communications, the different types of new wireless communications like LoRa and Sigfox and other things which are giving access and which is popular in agricultural systems at the moment. Drone technologies. I'll just do a bit of a plug about an article that I've written and online about drones and how it can be used for locusts. So I'll give that plug at the end. And robotics and automation and gene editing. All these different technologies are slowly being adopted across the whole of the agricultural sector. So you might have heard of smart agriculture, digital agriculture, e-agriculture. These are all fairly similar titles for the same thing, and that is for how we can use information communication technologies to support farmers to produce more food and to maintain a stable agricultural industry, to maintain livelihoods of those farmers and other associated workers. So in terms of how ICT can be used, we have traditional approaches, which are the use of biometrics and crop modelling. And we also have the use of precision farming, which is really attuned to using GPS technologies. Artificial intelligence and image processing techniques are some of the approaches. All these approaches are really aimed at how we can improve the capacity of farmers and other associated consultants, government officials, to be able to make more informed decisions about the way crops and other food products can be made, made or grown most effectively. And that efficiency of production is really across the whole of the supply chain, from both the paddock or the field or all the way to how the food gets onto the plate that we are eating from. So smart agriculture is involved in many aspects of the food cycle, from farm planning, from the accounting and management of the actual whole farm company itself, the management of the crop, also in terms of the management of the soil and the water associated with the farm itself, also in terms of pest and disease management, in terms of perhaps in terms of horticulture, it could be in terms of the orchard or the fruit production as well, or in terms of other factors, it could be soil or other kind of fertilizer management that is required. So it's across the whole aspects of the farmer's lifestyle that needs to be considered. So the actual land as well as the cropping cycle. So smart agriculture can be considered, the number of technologies that are used in smart agriculture are quite extensive. I'll just list some of these. These are the kind of things that you can consider as contributing to smart agriculture. So we have artificial intelligence and machine learning technologies, image processing, sensor technologies, drone technologies, different robotics, big data and high-powered computing systems, cloud computing, IoT technologies, mobile apps. And I've just listed here some of the things that we can use some of those technologies for. And in this talk, we're talking about some of those technologies and the research that has been done on those technologies. As I said, digital agriculture is really there to, its main goal is to work so that we can improve farmer decision making. So it's there as a tool to assist the farmer. Farmers are very smart. They have years of traditional knowledge and years of experience in how they have grown their crops. And these tools that we are developing are there to provide further assistance for them to make those decisions using the data and the analytics that we can give them to help them in that delivering that choice. In terms of the processes that these kind of tools can be used for, it's more about developing the tool based on supplying different data sets, which may come from satellite data or wireless networks and sensors, or from historical data. You just look up here at this image on the right. So it's satellite data, wireless and sensor data, historical data, climate data, or crop data. So all that different data comes in different forms, and as a digital ag person, we will try and use that data to develop knowledge for the farmers to be able to work with different aspects of their system. So that could be how they store the grain, how they crop their land, how they manage the land or manage their finances, how they manage their tractors and their other equipment. It could be how they manage their livestock. So this is what we're looking at in terms of that's the ultimate goal. The farmer decision making is along the lines of different parts of the supply chain, and we need to think in terms of how we're going to help the farmers make decisions at different parts of that supply chain. So in terms of this, I've just got a little diagram down the bottom here that explains the Australian food supply chain. And that is pretty similar to the Indian, not exactly similar to the Indian supply chain, but we have from the farm gate, we transport and load, store the food, and then we would process, grade and process it, clean or package the food, then manufacture it or process it so in wholesale, so it becomes wholesale, and then transport it from different storage to different retailers or would export it. So in that whole supply chain, we can have different tools, digital tools, which can help in that and developing decisions about that. We have, in terms of the growing of the crop, the planning of what variety, seeding, spraying, harvesting, transporting, and selling our product. Okay, so that's a little bit of information about why we are doing digital agriculture, some of the factors and issues we need to consider in doing this research. So the areas of research that we're looking at in terms of digital agriculture is artificial intelligence and decision support systems, agricultural informatics, environmental sensor networks, Internet of Things and cloud computing, geospatial technologies, mobile and web apps, and also data security. So you can see that artificial intelligence and decision support tools, that's just one aspect of the areas of research that we're working on in terms of digital agriculture. The technologies that are behind some of the AI and decision support tools that we develop for agriculture is data mining, artificial neural networks, Bayesian networks, support vector machines, statistical analysis, linear regression. These are some of the tools that we're using, the back end that is developing our artificial intelligence tools, our decision support tools. So for those of you who do not know what the basics of the decision support tool is there to take raw data, find information or knowledge from that raw data, develop it in a repository that can be used and mined to find information that can be then used to make predictions about different aspects of that data under different conditions. So the raw data can come from many different aspects in terms of agriculture. We'll talk about that in later slides. We need to pre-process that data, and then we mine that data for information, useful information, and we can use different types of ways of doing that: association rule mining, classification, multivariate regression mining, various different ways that different types of data mining techniques are there, and that will allow us to develop different predictions or correlations with the data sets that we have. For some of the data sets, some of the tools that are used, these data mining tools are integrated into other tools like OLAP tools or optimization tools to be able to develop decision support systems which can be used by different users. So it may not just be the data mining tool, we may also have other tools that are associated to get the answers that we want. One of the tools that my group has developed is the Ag Data Decision Support tool. And this is just a graphic explaining what this tool was in terms of its design. So the idea of this tool is to allow farmers to be able to look at different cropping scenarios and see what happens under different rainfall and weather conditions, what kind of crop yields and crop quality that they were likely to get in different locations. So it had a basic web user interface, and the user would input on different kind of drop downs in terms of location and rainfall weather conditions, and using a prediction module which used machine learning, which is neural networks, it was able to make predictions. The predictions were put on a nice kind of representation in terms of graphs and maps, and that provided a nice clean tool for farmers as well as consultants and researchers to use. So this is the Ag Data tool that we developed using R and Shiny apps and neural networks. Some of the screenshots from this. So we had just visualizing the data sets, the data for the farmers, showing what kind of crop yield we would get under different scenarios, and what kind of variations that we'd have across different crop varieties, for example. Another tool that has been developed by my former PhD student from Mumbai Uni, Dr. Nikita Gandhi, who is, I think, listening to us today. This was a tool that she developed for Indian rice production, and the design of the tool was that it had an interface layer which provided decision support tools and visualization tools, and it took in different crop and soil and crop, soil and weather data, and using different SQL queries and some data mining, it was able to predict crop yield predictions under different cropping scenarios. So it used also a quite extensive database which was collected from different zones across India. So this was the overall study, mostly in different districts of Maharashtra and also different climatic regions of India. So she used predicted rice crop yields using neural networks and found which was the most appropriate algorithms to use, neural networks algorithms to use. I think ANN was decided to be the most appropriate one. So this is just some of the interfaces of this tool. Another tool that was developed, which we used different AI techniques, was some work that was done in Thailand, and that was looking at predicting vegetation change under different drought conditions. This used basic association rules and also neural networks to make these kind of predictions. And it was looking at trends in the different types of forests under different drought conditions. So this looked at seasonal variations in the vegetation types. And this used different satellite imagery as well as data which was collected on CO2 levels. This study used neural networks. So it's using ANN type neural networks to predict what was the changes in vegetation under different climatic change scenarios. So this is some of the work that has been published in a journal. So that was just a quick introduction to some of the AI techniques that we're using. The other aspects that we're looking at is image processing. Image processing work that's been done by myself and my students is for both medical images as well as agricultural images. So we have developed quite a few different techniques for different automated approaches for identifying cancer cells and those kind of things. All these different techniques can be applied to both medical and agricultural images. We've also done some work on plant image processing using different automated approaches, and some other different techniques we've looked at using kinetic cameras and other deep learning approaches for image processing, which I won't go into today. So some of the medical image processing tools that have been developed for histological slides. So those tools and techniques that we've developed, we're now applying to agricultural images. There's been quite advancement in the use of image processing in agriculture and horticulture, and it's mostly been around assessing whether fruits or horticultural crops are ready for harvest. So this kind of image detection and video and image streaming to detect whether a particular tomato, for example, is ready to harvest. And it's also been associated with robotics as well to automate those processes. Other aspects of image processing has looked at aspects of leaf disease identification using image processing. So there's a lot of work done in this area, and this is some of the techniques that we're looking at here. Some of the new, the more popular neural networks like GAN we're using on medical imaging. We're also trying to start to apply to agricultural images as well. Another interesting aspect of image processing, which is using drone images, and this is one of my colleagues from DBIT, the Department of Agriculture in Western Australia, who is using 3D imaging and 3D imagery and drone images to actually record crop growth. And that's using, just taking these images, and I think this is chickpeas, I think. Yeah, it's a field trial of chickpeas, and he's trying to assess crop growth patterns. It's a very interesting, exciting area. Got other former students who have developed different automated tools for assessing different leaf shapes and designs and classification. Some of the earlier work we have done. Some of the other aspects of research areas that we're looking at the use of geospatial technologies, and this is looking at how we can use satellite imagery to manage watersheds and drought prediction. And we've also looked at geospatial data mining and hotspot analysis techniques. So these are some of the associated AI techniques that we've been using. This is a study which was done in Andhra Pradesh, looking at some of the watershed management issues in Andhra Pradesh. This is one of my students who was studying at Edith Cowan University, but he was from India, from Hyderabad actually. So we're looking at different geospatial techniques to look at the different aspects of the catchments and work out what predict land use management and land use changes. Some of the more complicated research that we're Sorry about that. So another study that we've been working on is the use of just skip this slide. Sorry, I skip this slide. The other areas that we've been working on are sensor networks, Internet of Things and cloud computing. So this area we've just got into in the last probably 2 or 3 years in a big way. So we're looking at low-cost sensor networks as well as developing smart farm networks and also using sensor networks for an automated irrigation processes. So one of the studies that both myself and Dr. Tripathi have been involved in Thailand is using sensor networks for mist spraying in mushroom farming. We've got a little project over in Thailand. We've also been looking at LoRaWAN and software-defined radio technologies. These different types of technologies, how we can use those for managing crop production. I have a student who has just started to work on this, and we're looking at developing those systems to how we can integrate them into developing like a smart farm. So this is all new, exciting research that we're just starting to undertake, but it's also using AI at the back end. Here's a low-cost weather station.
We're also developing low-cost weather stations.
Sorry. I've used this slide from another presentation. So we've got low-cost weather stations, and yeah, that was a really good project that I was working with some students, Indian students, to develop, and the guys at in Hyderabad at GIZ to develop low-cost weather station that could be used by different farming communities in India. Another interesting aspect that we're looking at is vertical farming and how we can integrate sensor technologies and AI to manage these vertical farming setups. And there's a number of vertical farming setups that have been established in Australia. It's just started in the last couple of years. So there's another aspect we want to integrate some of these AI and image processing techniques. The last technologies that we've been using, which is integrating in some way AI techniques as well, is developing e-learning systems and mobile delivery systems and also VR systems for agricultural education. So these are some...
We're also developing mobile...
Sorry about this. So we have mobile apps. So this is technologies that were used, just simple basic technology that we developed in Thailand. A new tool that we've just developed along with Dr. David Cook and some other students is developing education apps, looking at showing city kids what farms are like, what farms in Australia are like, and educating them about how food is produced. So these tools that we're developing, that's been a lot of fun. Okay, that's my talk. Thank you very much. Sorry about that little glitches of some of the slides. Thank you very much for the presentation. I'm not sure how long I went for. Not sure if it was long enough.
Thank you so much, ma'am. It was a wonderful session, very informative. Now we have some question answers our students have asked. So, may I ask, ma'am?
Yes, sure.
Yeah. So the first question is, how far do you think this technology and digital agriculture methods are used in developing countries like India?
I think these technologies are being equally used in India. In fact, I think some of the technologies are being adopted faster in India than they are in Australia. So in terms of especially some of the mobile technologies, there's a number of mobile apps, farmer apps, which are being developed. I'm not sure what the uptakes are in terms of the whole of the farming communities, but there's a big push for digital in India and digital ag in India. So I think it's a new burgeoning area, definitely.
Okay. So as far as engineering students, how do you think we can start with this? Like some basic projects or techniques that you would recommend for better understanding of digital agriculture?
I think I showed quite a number of different little projects there, which were pretty much done by research students as well as myself. So for all the DBIT students, I think you need to talk to Dr. Tripathi, because he's the main person that I've been working with in terms of the digital agricultural projects. So for the students who are from DBIT, I think you need to talk to Dr. Tripathi and myself. We have lots of different fun projects in this area. And in terms of work in the area, there's a number of different companies doing digital ag projects, TCS and other Reliance, other big companies are starting to fund digital ag projects. So yeah, I think there's a lot of work out there.
Also, what was your thought process behind choosing this career path specifically?
Why did I choose this career path?
Yes, ma'am.
That's a good question. I can't really answer that question. It will take like a couple of hours to answer that question. Yeah, I think I just decided that I wanted to do something that I love to do. So I just follow, that's my adage, I follow and do things that I'm interested in. So that's what I would say to any student, do things that you're interested in, not, don't always listen to your parents telling you what to do.
Yes, ma'am. Also, last question.
Yeah.
Which are the current market leading tools or softwares used in digital agriculture?
Which are the current what?
Current market leading tools or software?
Marketing.
Market leading.
Sorry, I didn't get that. What you were saying.
So, ma'am, which are the current leading tools or softwares used in digital agriculture?
Different softwares that are used.
Yes, ma'am.
Software tools. Sorry, I didn't get the second word that you were saying.
Yeah, software tools are what I'm asking about.
Oh, software tools. You mean programming tools?
Yes, ma'am. That too, and like what all is used totally.
Well, some of those tools have been developed in R and Java, Python. So most of the image processing work has been done in MATLAB. So the web tools that we use are Shiny apps, different mobile apps. So we're pretty much diversified in terms of the tools we use. It depends on what we're trying to do.
Okay, thank you, ma'am. So if any other teacher has any question, they can unmute and ask.
Yeah, if you want to find more information out about some of the things I've talked about, because I've only just skipped through a lot of the things about what we're doing, you can email me about that. My email is there.
Leisa, I have a question. Leisa, I have a question.
Yep.
So, see, in this pandemic, lot of industry or any other things has not worked, but this agriculture has been worked throughout the world. This agriculture sector has not stopped working during this pandemic. How do you see? How do you see that one? The future of agriculture, in particularly digital agriculture, and the ongoing agriculture with respect to this pandemic.
Yeah, I think I think that there's still in Australia the agricultural sector is still going on. I think we did have problems initially in Australia with supply chains and getting food to the shelves kind of thing. So those aspects of the supply chain have been a problem. I think probably in India also you had those issues. I think what we found in most industries now with the pandemic is that we've become a lot more online in terms of how we do our businesses, and I think that may be beneficial for some of the agricultural sector in India to develop more online processing or marketing of goods in terms of making it so that there is not so much food wastage, that issues that you have in India, to find ways to better distribute the food in terms of food supply chain. So I think, I'm not sure exactly what you mean by how digital agriculture can affect, influence those aspects.
Okay, one more question I have this with respect to, as you talk about the population growth and the so-called food security, which is questionable in upcoming years. So with the digitization of these things, how do we see that one, the gap can be reduced?
The gap between
food security, yeah.
Or the gap between what food we have and what in the population. I think we need to start being a bit more radical in what types of crops we are growing and how we are growing them, and also find crops which are more suited to the more extreme situations of drought and more adapted to extreme conditions. I think that will improve the food production per square hectare for us. Or also we may need to think of other types of food, maybe other protein sources rather than just, so the types of crops we grow may need to change. So we basically need to find a higher productivity and also lower wastage of food. There's so much wastage of food also. I'm not sure what the percentage of wastage in India is. I think it's 30% or something. Of food gets wasted or not delivered. So those issues need to be thought of as well.
As you have been seen or many times to have been in India, and you have also worked with NGOs, and you have your own NGOs over there for rural development, particularly with the things. So how this digital things will help to upgrade the situation that as an Indian context is concerned, I know India very well.
I think it needs to it may not work at the individual farmer level, but I think at the district or the village level, I think we can introduce some of these digital applications to improve the kind of cropping decisions that the growers are making, and definitely ways that they can market and sell their goods efficiently and effectively and get the most money for their crops. I think that's probably at the village level. I'm not sure individual farmer level, but at village district level, we can use it. I think some of these tools at farmer level, perhaps the plant pest and disease identification apps, those kind of things will help farmers. Just basic crop agronomy tools as well will be beneficial.
So do you think that the digital agriculture means provide an employability towards the farming sector?
I think if it can make the farming sector more profitable, I think it's going to lead to less migration of locals to the city, because I think that's the issue at the moment, in that the internal migration of people coming from different states, because there's just not enough work, and the sustainability of the farming sector is very low, so they're having to leave and seek work in the city. So I think we need to try and improve the profitability of the farming sector, and that may keep the more stable population.
Okay, thank you very much. Over to Mansi.
I have one more thing before we go. I'm just advertising my. This is an article I wrote for online site, which is a very interesting site to have a look at for all things related to science and politics and art. It's called theconversation.com. I've written an article just in the last couple of days about how we can use drones to help solve the issue of locust swarms. I know you had some locusts. Did you have some locust outbreaks recently in India?
Yes.
Yeah, so your students and yourself might like to look at this article.
Sure.
And comment on my article, see if you like it. I did mention India in the article, so I'm just plugging that at the end of my talk.
Okay.
And another, I have another book that's out on use of, it's a digital agricultural book, which I will give the link to Dr. Tripathi to show some of the chapters that have been written in that, which would be interesting for your students to have a look at.
Yes.
So thanks everybody. Sorry about the few glitches I had with a couple of the slides. I'd copied them from another presentation.
Thank you so much, ma'am, for answering all our queries. Now I would like to invite Mayura Gavane, Professor in Computer Department, to propose the vote of thanks.
Thank you, Mansi. Good morning, all. It's my pleasure to present the vote of thanks to all who have helped us in making this webinar such a resounding success. First of all, I would like to propose a hearty vote of thanks to Dr. Ameya Kumar Tripathi for gracing today's webinar. Thank you, sir, for your very interesting and thought-provoking address. I would like to thank our distinguished speaker, Dr. Leisa Armstrong, for making excellent presentations. Your insights on digital agriculture were interesting and thought-provoking. Also, the work you have done on your research topic is vast, and I hope many of the students will be inspired from your dedication. I would like to express our profound gratitude to our principal, Dr. Prasanna Nambiar, for her constant support. I would also like to thank our beloved HOD, Ms. Sana Sheikh, for her moral support and guidance. And I would like to thank Dean Administrator Mr. Imran Ali Mirza and Dr. Firoz Sheikh for their constant support to make this event success. I am happy to express vote of thanks to our staff members who have made this webinar a grand success. I would like to thank the student volunteers team who has worked really very hard in making this event a huge success. Thank you so much, all of you. Finally, the wonderful participants who have turned up in such a great numbers, not only from our department, but also from other colleges. Thank you so much for your cooperation. Once again, I thank all for your cordial cooperation. Thank you.
Thank you, ma'am. Signing off.
Okay, thank you, everybody. I hope you enjoyed the presentation.
Thank you,
Yes,
Lisa.
ma'am. Thank you.
Okay, bye for now.